Good morning, everyone. I'm going to be teaching and showing you how to solve um, absolute value equations and also absolute value inequalities. And also, if we have time, we can also do finding the domain and a function. So here's an example. This is what an absolute value equation looks like. Okay. Now let me check to see if this is being recorded. It is. Great. Okay. So now, okay, so what is the meaning of this? What does it mean, the absolute value equals to 2? It means that we're looking for the solution set of numbers, all the numbers whose distance from 0 is 2. Notice that I use the word distance. This is one of the reasons why we use the absolute value is to measure distance. So as you can see from this real line that I drew, that the distance from 0 to 2 is 2. So the distance is 2. Okay. But also the distance from -2 to 0 is also 2. So this distance is also 2. So what does that mean in terms of solving the absolute value equation? Well, it means that this is equivalent, that arrow pointing both ways, it means equivalent is equivalent to 2 equations. Here's the first one, and here's the second one. And that is the solution set. Our solution set will be -2 and 2. These are the only two numbers that whose distance from 0 to -2 or to 2 is exactly 2. Again, distance is 2. That's what that means. Now we're going to use the same approach to do more complicated ones. Okay, here's an example. Okay, so now you don't have to do the table that I did. You don't have to do the graph that I did. All you have to remember is that this is equivalent to 2 equations. Here's the first one. Or 2x plus 1 equals 3. Okay, so let's go back to what I just did. You see, here's what x is. This is what's inside the absolute value. In this case, was a single x. And from it, I created 2 equations. This time, inside the absolute value, I have 2x plus 1. So I create 2 equations. Also notice that in this example, I have to consider -2. Why? Because the -2, the distance from -2 to 0 is 2. So that has to be considered, which is why when I do this equation, I have to consider -3 as well. So now all I have to do is solve. Well, let me move that one over. So this is -4 divided by 2, and you get -2. So that's one of my solutions. Here's the other one. Divide by 2, and you get equals 1. So how do you write the solution? The solution set, you create braces, and you put -2, comma, 2, and then close the braces. Now, when you're doing this, and Alex will provide the braces for you. All you have to do is click to access the braces. And then all you have to do is fill in the blank, -2, comma, don't forget the comma, 2, okay? Let's do another exercise. This time, we're going to introduce our second scenario. See? So now is the absolute value of x less than or equals to 2. Okay, so let me tell you what that means. And the way to do that is that I do a little graph. And here's 0. You notice that I always use 0 because we're measuring the distance from 0 to that number. Okay, whatever number that is. So now what I'm looking is not just two numbers, like in the previous two examples, where my solutions were single two numbers, two more, nothing more, just two numbers. This time, I'm looking for all the numbers whose distance from 0 is less than or equals to 2. That's what I'm looking for. So if you look at the graph, I'm going to use red here. All of these numbers, the distance is less than 2. All of them, including 2. And guess what? Here too, all of these numbers, the distance is less than or equals to 2. So that is the solution on the number line. The question is, how do I write that as an equivalence? What does that mean? It means that this is equivalent to this. In other words, x is sandwiched between 2 and -2. That is what this is equivalent to. Notice what the x went. The x, whatever is inside the absolute value, is going to go in the middle. Okay? And then you're going to have this is called the upper bound. The -2 is called the lower bound. So that's what this is. And that's it. So how do you write that in interval notation? So we write it like this. Now these are brackets, not braces. And this is called interval notation. Here's the graph of the solution. And then you have the interval notation. This means that I can include -1, -1.1, -1.99. There's infinitely many numbers that satisfy that condition. Okay. Now you may be wondering what happens if instead I only had this. Okay. Well, in that case, this will be less than, but not equals to 2, or greater than. X has to be greater than or to -2. So how does that change? How does that change my answer? If that was the case, the only thing that will change is that instead of using brackets here, we're going to use parentheses. Okay, so my solution will now be from -2 comma 2 close parentheses. And that has to do with the fact that now this is only less than or equal, not equal to, only less than 2. The distance is only less than 2, but not equals to 2. So in that case, what we need to do also is change this. And how do I do that? I can just put a parenthesis there. Okay. Now, in some cases, Alex, when you're doing this in Alex, they will do this. They will open up. They will have an open circle, meaning that endpoint is not included in your solution. Now, the way that you do it when you use an interval notation is that you use parentheses, not brackets. Okay. All right, let's do one that is a little bit more complicated. Let's do x plus 4, absolute value x plus 4 less than or equals to 5. So right now, before I even compute the problem, I know that my solution will have brackets. Why will it have brackets? Because of this. Okay. And then what I need to do is write down what this absolute value inequality is equivalent to. If you remember, here I took the x and I put it between the two numbers. Okay, so I'm going to do the same here. So I'm going to put 2x plus 4, and this will be sandwiched between two numbers, 5 and -5. You see? It's the same principle. It's just that what's inside the absolute value this time is not just x. It's x plus 4. Where did I get this 2x plus 4? My bad. It's just x plus 4. Okay? All right. So notice again, this is where that comes from. And then all I have to do is solve for x. How do I do that? I need to subtract 4 everywhere. Here's my x. I want the x by itself. Okay. And so there it is. This is my interval, and the interval notation will be from -9, comma 1, close the brackets. What will be the graph of it? The graph will be some line like this, and you will have -9 here up to 5. So the solution of this problem will only come from, this is key, come from this interval, only from there. If you go outside, then you get no. Okay, so we have to be very careful with that. And again, I keep repeating that the reason why we're using brackets is because of this, less than or equal to. Had it been only less than, then we would have used, the answer would have been -9, comma 1. Okay, just keep that in mind. Then we have the other case. This will be the third scenario where you have this. You see? So pay attention closely to the inequality sign. That's the key. That's what makes this so difficult, because the students confuse all three cases and they treat all three cases the same way, and that is totally wrong. The fact that this is greater than or equals to 2 means something. So let me show you what that means on the number line. Let's do it at the bottom. 0. Okay, and here's 2. Here's -2. Okay, so now what am I looking for? I'm looking for the number whose distance from 0 is greater, not less than or equal to, but greater than or equals to 2. What does that mean? It means that this time all of these numbers pointing in the opposite direction will be my solution, creating a gap. And this gap is not part of my solution. Okay, so pay attention closely to the direction in which the inequality is pointing at. This is crucial. You cannot ignore that, because if you treat them all the same, then you're not doing it right. So what is this equivalent to? Okay, well, this is equivalent to, I'm going to create two inequalities. I'm going to create one for this one. I'm going to have x is less than or equals to -2. That will take care of this section. And then I'm going to use the word or. And then I'm going to create another equality that will represent this section. And that will be x greater than or equals to 2. You see how different this is compared to the other example. Okay, so this is again something that you cannot shy away. You have to overcome these inequalities, and you have to learn it, because it's not going to go away anytime soon. So how do we write this now in interval notation? So let me erase this because I need some space. Okay, so now we're going to say from -infinity, comma, -2, brackets, that will take care of this part. And then because we have a gap, we're going to use the connected or, the symbol or, represented by the U. That means union. Okay, so U means union. And then I'm going to write brackets 2, comma, to infinity. So there you have the graph of the solution. There you have the two inequality. There you have, and also you have the interval notation right there. So there it is. Totally different answer than this example. Look at this example here. You see, our answer was here, not here. But when you switch the inequality the other way, then that changes the ball game. Okay, it's pointing in the opposite direction. All right, so let's do one where we have to do more work. Okay, so let's say you have 2 upside the absolute value. You have 3x minus 1 greater than or equals to, let's say, 10. Okay, so how do you do that? All right, the first thing you do is look at it and say, is my solution will have a parenthesis or a bracket? That is the first thing that you do. And I can tell you by looking at this that it will have a bracket because of that. Another thing that you should know is the way that this is pointing at, because it's pointing saying that the absolute value is greater than the number 10, then because of that, we're going to create a gap automatically. What gap am I talking about? This gap, okay? This gap. That means that we're going to create 2 inequalities. Now, before I get to it, before I get to the actual process of solving it, I need to take one step first. First, I need to divide this by 2. And so now this becomes 3x minus 1, absolute value of 3x minus 1, greater than or equals to 5. You see that? Don't forget to do that, okay? You only divide this 2 here, and on the other side of the inequality, you do not divide inside the absolute value. You don't do that. All right, so now I'm going to create 2 inequalities. Here's one. Switch the sign and the sign of the number. Use or, and here's the other one. This is the example in which you're going to have 2 inequalities, and you're going to have on the number line, they're going to be pointing in the opposite direction, hence creating a gap. Okay, so I'm going to solve this one. This is going to be -4 divided by 3. So I'm going to have x is going to be less than or equals to -4 over 3. That's going to be one solution. And then I do the same here. This is 6. And so now this means that x is greater than or equals to 2. 6 divided by 3 is 2. Okay, so how do I write that in interval notation? So let's do that first. Let's do that. This will be from -infinity up to -4/3 brackets, union, and then I write this one. That will be from 2 to infinity. That will be the solution. Now, when you look at the graph, let's see if I can erase this, then you will have some number here, -4/3, point in this direction. You're going to have your gap, and then you're going to have 2, then point in the other direction. Okay? There you have the 3 different scenarios that will come up in module 1. Okay, so now let's see what comes up. First example, x plus 1 less than 4. And 2x minus 1 and less than or equals to 5. Okay, so this is revealed. So which scenarios do we have? Is this scenario in which we end up with a gap in between? Is this a scenario? No, this is not the scenario. The other thing is the first example, number 1 here, will have a parenthesis. The one at the bottom will have a bracket. Okay, so what is this equivalent to? This is equivalent to -4, and then you put x plus 1 less than or equal to, I forgot that, and 4. See? So basically, x plus 1 is sandwiched between 2 numbers. So whenever you have this, think of a sandwich, okay? And then we have to solve for x. Here's the x by itself that I wanted. And so x is between Here's an overlay. -5 and 3. So x is here. That means that as long as you pick a number from that interval and you substitute it here, then you will end up with a true statement. So let me give you an example. Suppose you pick 2 from this interval. So 2 plus 1 is 3. Is the absolute value of 3? 3. Is 3 less than 4? Yes. And that will happen for all of these numbers in this interval. Now, if you go outside the interval, then you will get a false statement. Okay. Again, let me repeat again. I'm using parentheses. Why? Because this is only less than 4. It's the less than. Okay, not equals to. Now, this one, on the other hand, this one will have brackets. And why is that? Because of this, because of the less than or equal to part. So let's see if I can solve this here. It might be too tight. So you have -4, 2, and this will be 6. Then I divide by 2 everywhere. So my x will be less than 6 divided by 2 is 3. And -4 divided by 2 is -2. So my x is here. It's sandwiched between -2 and 3, including the endpoints. So what is my solution? How do I write it? Okay, so by the way, here's a solution for the top, the one on the top. The solution for the interval solution for the one at the bottom, number 2, will be from -2, 3 brackets. And there you have it. Okay, no gap in this one. No gap in this one. Let's do more. Let's do this one. Okay, and then we'll do this one here. There. Okay. Now this ones, both of them will end up with a bracket. That will be clear. But this is the other important information that you need, that this will have a gap. Why? Because it's greater than or equals to 2. And we already said the reason why. So we're going to need to create 2 equations. So this is equivalent to, here's the first one. Okay. Now, you may be wondering, why did I write x minus 1 less than or equals to -2? Why is that? Let me go back. Here, you see? Since I'm creating a gap, and these numbers, their distance is greater than or equals to 2. The distance to 0. That means that I can create this gap, this interval. Well, this interval means that x has to be less than or equals to -2. That's why all of this is connected. Okay. All right, so I'm going to do the same there. Now it's just coincidence that it's -2, but it doesn't have to be. That's the other one. So it's 1 plus 1. So that would be x less than or equals to -1. And then I do the same here. So these are the ones that are pointing in opposite directions. Okay. Let me erase this so I can show you here. Here's 3. So it's pointing this direction. And then you have -1 pointing the opposite direction. And there you have your gap. You see? So I know that when I have greater than or equals to, or greater than, I'm going to end up with a gap. Okay? So how do you write that in interval notation? So we're going to squeeze it in here. It will be from -infinity up to -1. Brackets, again, why am I using brackets? Because of the greater than or equal to. And then I use u. Why do I use U? Because I want to connect, the two solutions, this one and this one. And so I do that by using the U. So this is 3 to infinity. There you have examples of those two. Okay, let me carry this one to the next frame. Was plus 4. Okay. Greater than or equals 2. Just leave it like that. Just greater than 1. Okay. So what is this equivalent to? Okay, so here come my two inequalities. There. Please remember to do that. And there's a reason why that I already stated and explained as to why. At this point, it should be just become mechanical and just get it done. There. This is pointing to the left, and this will be pointing to the right. This will be -3. Okay. Under number line, I think this helps a lot of people here. This will be -5, pointing this way. Here's your gap, and then you have -3 and point in the other direction. So the interval solution would be from -infinity up to -5, not including -5, which is why I'm going to use a parentheses, union, and then -3 to infinity. Okay, there you have it. There you have it. You have different scenarios. Let's do one more, and that will be it for this topic. This topic right here, 10 equals 2 pi. So this is the equal. This time, you're going to create two equations. Here's the first one. Here's the second one. I don't want to divide, I'm subtracting. You see? This becomes -15 divided by 2. You get -15 over 2. The other one would be -10 equals to -5 divided by 2. You get -5 over 2. So you have -5 over 2 and -15 over 2. Now, the solution, the way that you write that, this is the only time that you use braces, is to list items, 15 over 2 and 5 over 2. And that's it. Okay, so there you have, this is how you solve absolute value equations, absolute value inequalities. Keep in mind that when you have something like this, a number here, and then you have something here, they're all treated differently. And this is something that you cannot ignore. Okay, this is a number. I'm using this symbol to represent a number. Okay. And once you understand that, then pay attention to this. This means something. This means something. And the last means something also. They all mean something different. You cannot treat them all the same. This is where the students make a mistake. They think it's the same, and it's not. Each one is saying something else. Okay. All right. So now I'm going to talk about finding the domain of rational functions. Of rational functions. Okay. First of all, this is what a rational function looks like. This is the most basic one. And what makes it a rational function is that we have variables in the denominator. So the x here is in the denominator. Okay. Here's another example of a rational function. There. Okay. So why do we study this, and why do we need to know the domain of them, and how do we find the domain? Before I do that, I want to review. Remember that when you were in middle school, high school, they told you that you cannot divide by zero. You cannot divide by zero. Okay. So we know in this case, in the case of f of x, that x cannot be zero because you cannot divide by it. So the domain is all the real numbers except zero. Okay. So the key is to find first what makes the denominator zero. Once you know what it is, then everything else is your domain. In this case, what makes the denominator zero in the case of f of x was zero. So what is the domain? Everything but zero. Okay. Second example. In this example, we need to know what makes the denominator zero. So let's find it. This time, I cannot let x equals to -1, because -1 will make the denominator zero. And if the denominator is zero, then the whole rational function becomes undefined. Okay, so I know that my x cannot be equals to -1. So what is my domain? Then my domain is everything on the number line except -1. Okay, so how do I write that? Well, I'm going to squeeze it in here. You see, there's your u again. You see, that's why we have to talk about union, because it's very useful. Okay, on the number line, the graph of the domain, there will be a gap at -1. And on this one, there will be a gap at 0. And we connect the gaps using the u, just like we did before. Okay, here's another example. Okay, this is also a rational function. Notice that we have 2x at the top and x squared minus 9. Notice that I didn't say anything about the numerator. The numerator could be 0, could be anything that it wants, and it's fine in this case. We always worry about the denominator. So the question is, what makes the denominator 0? I don't want it to be 0. All right. This is factoring by, this is the difference of two squares. So I'm going to factor this. I solve for x. And I get that x, in this example, cannot be equals to -3 or 3. What does that mean? It means that if x becomes 3, then the whole rational function becomes undefined, and I don't want that. Okay, that's exactly what I'm trying to avoid. I'm trying to avoid having this function undefined, because then it's useless for me. Okay, so I need to know first what are those numbers that makes the denominator 0. In this case, those numbers there are two of them, 3 and -3. Now that I found them, then my domain is everything else. On the number line, you're going to have two gaps. This is good, this is good, this is good, but now you have two gaps. So how do I write that in interval notation? So here it goes, -infinity up to -3, union, -3 to 3, union, 3 to infinity. So this one represents this one here, and this one there. There you have it, different scenarios, okay? I didn't do anything to the numerator, nothing. Everything is what is happening to the denominator, and that's what I worry about. Here's another example. There. And the instruction would be find the domain. Now, notice that they're saying find the domain. They don't say what makes the denominator 0. Be careful with that, okay? So to find the domain, the first thing that you need to do is find what makes the denominator 0. I need to factor this. So in this case, x cannot be equals to 2 and 1. Remember, x and 2 is not your domain. In fact, it's the opposite. It's called the complement. Okay, so here's the number line. Here's 1, and here's 2. Okay, so we want to include this one, this little gap, this little section there, and this one. So how do I say that? It goes from negative infinity up to 1. Okay, that covers this section. Union from 1 to 2. Union from 2 to infinity. And there you have it. That would be, this will be equals to your domain of the function f. Now, to get to it, I first need to find what makes the denominator zeros. Okay, so it's a process, and this is going to take practice. This is not going to come to you overnight. This is going to take practice. You're going to make some mistakes. You're going to learn from the mistakes, and you move on. One thing that you cannot do is postpone this, thinking that, okay, I don't know this, let me move on, because it will catch up. It will catch up on you. Okay, these things don't go away. There's a reason why you're learning this. Okay, so this, all of the examples that I gave you here, all of these are rational functions. Now we're going to do radical functions. Okay, finding the domain of a square root function, the square root of something. Okay, we're going to do that one. We're going to do this one too. Those two. Now these functions are different. They're not rational functions. And because of that, they have their own unique way of finding the domain. And the question is, you might be wondering, why do I need to find the domain? Because eventually, we're going to learn how to graph each of these. And knowing what the domain is the first step required for you to graph it. Okay, so we're doing this in steps. All right, so this here, this is called the radicand. The inside of this is called the radicand. If you didn't know that, now you know. The radicand here is x plus 1. Well, when it comes to the square root function, we need to know that the radicand is always greater than or equals to 0. That's right. We don't want it to be negative. That's another way of saying you don't want the radicand to be negative. And the way you say that is you want the radicand to be greater than or equals to 0. Well, in this case, my radicand is x. So there it is. Greater than or equals to 0. That's my domain. Here's my interval notation of my domain. You see? That's it. That was simple. Of course, this is just the first example. The graph of this, eventually you're going to learn, is like this. So the reason why you need to know the domain is because it's going to, you need to know how to graph it. And to know how to graph it, you need to first know the domain, because that's where you're going to select the points to generate the graph. because if you select the points in the wrong place, you're going to make a mistake. So right now, we're just learning how to find the domain of these radical functions. All right, second one. What is my radicand here? Well, this time is x plus 1. And I want it to be greater than or equal to 0. So I solve for x. Move then 1 over to the other side, becomes negative. So what is that saying? It's saying that my domain is from -1 to infinity. Notice that in infinity, I always use parentheses. I don't use brackets. Always on infinity. And the graph of this, let me erase some of the stuff here. It's going to be almost the same as the first one, but it's shifted 1 unit to the left. So before, this is like shifting this one here, there. So it's shifted 1 unit. Then the shape of it is like that. Okay. So the key here is to know what the radicand is and work with it. All right. Let's do now this one. Okay. Question for you. What is the radicand? I put a 10 there, but that 10 has nothing to do with the domain. The radicand in this case is 2x plus 1, minus 1, greater than or equal to 0. Okay. So in this case, I don't do anything to the 10 when it comes to finding the domain. I'll use the 10 later on when I'm graphing it. But right now, we're not doing that. Right now, we're just finding the domain first. So the radicand in this example is 2x minus 1. And I know that my radicand must be greater than or equal to 0. So I'm going to solve for x. Divide by 2. What is that saying? It's saying that x is greater than or equals to 1/2. Okay, so here's my domain from 1/2, comma, to infinity. There it is. That's your domain. Repeat it. I'll repeat again. Don't do anything to the 10 when you're finding the domain. The 10 here is not inside the square root. So you don't do anything to it. You only do, when you find the domain, you only work with the radicand, which is here, there. All right. One more example, and then that will be it. Okay, so here it is. Let's call it g of x. Let's make it like this. Okay, minus 1, minus 10, whatever, minus 10, minus 1, it doesn't matter. What is the domain of this thing? All right, so it's not a rational function, so we treat it differently. We only care about the radicand. The radicand in this example, let me write the word radicand, is -2x minus 1. And we always put this condition. Always this condition. Okay. And now I need to solve for x. Okay. Now I need to divide by -2 this time. And because of that, this is something you need to know. We write x, and this symbol switches direction. Why? Because I'm dividing by -2, or if you multiply or divide by negative to any inequality, then the sign flips, switches the direction. And so now x is less than or equals to -1. By the way, -1 divided by -2 is 1/2. 1/2. So how do I write the interval notation of this? Well, this means that the domains are all x's that are less than or equals to 1/2. Okay, here it is. See, now I'm coming from the other direction and use brackets. I use brackets because of this condition, always. Okay, and there you have it. There you have the domain of radical function, the domains of rational functions, and how to solve the absolute value equations, absolute value inequalities. And there you go. And this is going to serve you for module 1. Okay. So I'm going to end the recording now, and I'll be sending you this so you can watch this whenever you want, but make sure that you do watch it because I'm not going to talk about this in class again. All right. Let me stop recording.